Oh, hey everybody. Can't sleep. Figured I'd just keep hacking on the thing that I was working on all day. It's like 2 a.m. here. So, did I work on the secure multi-party stuff in stream? We just did the basic secure stuff. We didn't do anything for multi-party beyond the sender and authorizer. You might be able to do it pretty easily if you were to tweak. What is it? I think there's a library that Stephen Deal had written that does kind of the same thing that I did, but he just has one data type for auth, which may or may not be auth. And if you get a thing, if you are going to run a thing and the thing is trimmed, then you read. Otherwise, you're writing to your log. If you were to tweak that a bit, you could probably make the whole thing. You might be able to make the whole thing work for multiple parties. I'd have to look at it. Maybe you need to have like a state that you read from and a writer that you log to or something like that. There should be something that can make the whole affair much more symmetric. What do we have here? So the thing that I was going to do just now, I fiddled with this a little bit off stream, and then I realized, if I'm going to fight with this code that we've written almost entirely on stream, I should just do it while broadcasting. That way someone can look at what I've done and why I'm doing it. So let me flip over here to that coding view. Close the old time window. So I did a small set of patches from, let's see here. I think we did through this commit. So what have I done since I broadcast? The first thing I did was just kind of go through and clean up some of this rank 0, rank 1 nonsense that we had, where we had the underscored versions of everything. Wound up just not needing them. Tweaked access just a bit just to make it return a word 64. Wrote a couple combinators that let me clean up inspect meta and inspect shape just by saying, hey, look, run through this list and then spew it out as these symbols. Not surprising, not earth-shaking. But it cleaned up a lot of the inspect blob, etc. stuff. Otherwise, went through put and built a couple of little combinators. I have this little push combinator that I'm using over and over again to factor out a lot of what used to be the logic that we were getting from bits. So that cleaned up meta and shape. I made it so that shape can actually write what writes to the metadata index as well, which then made put parens and all that redundant, or put paren redundant. I wrote a one-off combinator that in theory lets us write n bits, like n zeros, into the bit stream all at once. So that should help a bit with some of this nonsense. So now we can write a run of zeros into the meta buffer all in one go instead of doing them bit at a time. It was bothering me. So I did the math on this. This was like when I started realizing I'm doing this off stream. Maybe I should be doing it on stream. What else we got? Yeah, put parens just became shape now that shape writes to the metadata. Cleaned up some redundancies here. And then what else did I want to do? The other thing I started realizing was that maybe I need to kill all of the uses of generics SOP, which would really suck. But as far as I can tell, the generics SOP stuff, when you use their metadata, it does not include the strictness information. And I've been thinking about like this elision of parentheses thing that we were trying to do, where we were saying if the field is of known size, elide its parentheses. But there's also a little more. If the field is strict, you should be able to elide its parentheses and then kind of walk down into it, figure out where you came out, and keep going. Because if it's strict, the parentheses, which we're only using for lazy deserialization, don't help you anyways. So it seems to me that what I need to do is look at all of the strict parts of my data types as well. And that's starting to sound like the get and the put and the size are getting really heavily entangled. Like we have, I had one put class, but then puttable also needed sized. And so I'm thinking I might want to go through and glue all three of those pieces together into one data type, like some kind of profunctor that does the serialization and the deserialization together. That way the size, all that kind of stuff can be glued together. All of the type case work that's building this sum of, or this product of products and doing all the logic for it could be shared. And then that thing can be a profunctor, so you can map over it and stuff like that to make like easy variants for other things. At least that's the thought. And hi, Coding. Thank you for the hosting. Oh, it's auto host, so. He's probably asleep. Well, wait, he's in Russia probably. Or I don't know if he's in Russia. What else do we have? So I think that's the change, that the set of changes that I've made so far. And now what I'm doing is I'm debating about handling the strictness stuff, even though we haven't written the getter. And I'm also debating about fusing all of this stuff together into one profunctor. Any thoughts? Anybody who is still, who's been paying attention during the normal day streams? I don't know how much of this is new to folks who are awake at this hour and what's... what I should just dive right into. Can't do new haddock, it doesn't work. At least in this version. So the API I have looks like this. We have a put monad that goes through and builds a builder, basically. And then there is a get monad in theory that doesn't work yet. And it dumps out into this intermediate blob format, which is how many bits worth of index do I have? What's the top level like meta index? Is it shape or data? For the stuff that is shape, it all goes into this system of parentheses, and all the stuff that is data, it gets dumped into normal like data binary looking kind of stuff. And if I open up blob here, we can say something like, I don't know, run put I don't know, 1, 2 are word 8s. And that builds this monstrosity. But if I inspect that blob, it gets serialized out as just this raw stream of bytes, and there's been no parentheses put into it. But if we look at, say, hi, it does get parentheses put into it. And the parentheses are telling us these are the things that we need to know the positions of in order to navigate this efficiently. So last stream, we worked out that, like, when we first started doing this, we were saying if I go to store A, comma B, or something like that, it gets serialized out as a set of parens around the whole thing, followed by a set of parens around the two different parts. And this was 6 parens for a pair. This is what it used to be. And then what we wound up doing afterwards was tweaking it until we got to here. So the outermost parens kind of come in with you, and the set of parens only go around everything but the last field. And then the last thing we did was we realized that if A or B, like say you were doing something like A, B, C, if B was of known size, you didn't have to put parentheses around it if it was of a fixed size. So we did a bunch of stuff to do size calculations to see whether or not something was always going to be of the same size. So like if I inspect the blob that I get from serializing out just versus nothing. So nothing gets serialized out as just a 0 byte telling me what the constructor tag is. Just 12 got serialized out as the tag indicating what constructor it was. And then we can just move over to the right-hand side and start decoding the word 8 that we have for the tail. And then if I ask for the size of maybe word 8, I get the fact that that's a variable size, but if I ask for the size of a maybe unit, it's always exactly 1 byte. And so that thing could be unpacked without having to put parentheses around it. So either word 8 is computed to be exactly 2 bytes long. Either word 32, word 64 is computed as variable. It doesn't know how big it is, so it would put parentheses around it as needed. So if I had left 2 for either word 8, word 32, it serializes it out. Why is it not serializing the... Oh, it doesn't need to put parentheses because the last field is known. And then, but this thing itself is a variable size, so the parent would put parentheses around it. Okay. So this is scribbling out data into the appropriate buffers and doing all the things. So we still need to do all this, the deserialization stuff, all this stuff to try and maybe write it out more efficiently to files and what have you. That's all to do. And I'm thinking fusing all of this stuff together and deciding how to handle strictness might be something worth fiddling with. I don't know how much energy I have. Like I said, it's 2 a.m. or something like that. So this is going to be mostly a little supplemental stream. Partially for archival and partially to catch some folks who are in different time slots than I usually talk to. So the problem that we have is size and get and put are all in 3 different modules. And this sum of products, etc. crazy nonsense, isn't going to work for me for the new scheme. Do I have everything? Okay, I'm done with everything that I need to do to do this big change. So all right, so what do we have? We have a serializable A. Serial, let's make a data type for serial A. Serial AB. This has 3 parts to it. A needs to know the size. If you give me an A, I need to give you result of unit or something like that in the terms of the put monad. A to, let's just call it a builder or something like that. And then you give me a size, and you give me a blob and 2 cursors. And I will give you an A B. Something like that. This is like the serializer. These are the 3 parts. And put would be these 2 things working together, and get would be these 2 things working together. Succinct builder is so this builder thing is going to be a bit of a mess. It's need a better name than builder. Encoding, encoded, I don't know. Stream, it's not really a stream. So we have a little blob builder. It says something like, if you were to give me a we had 2 different types in there. It's like you gave me an S and I'll give you an S and a W, and previously I'd tupled that up into some kind of result type. And then S was a tuple of all those things. Let's go there. Monoid result. A to S to result. I don't even need the whole blob builder thing. I just need this thing. And then we wind up needing to build this build thing. Segfault, we're, how to describe this? We're playing around with building a little library for serializing Haskell data types out to disk, such that when I go to deserialize them back in, I only have to pay for the portions of it I look at. And I've done like a fair bit of work on this on the last 3 streams or so. It's more or less, I just decided, like, it's 2 a.m. here. I was fiddling around with this thing off stream, and I realized I should just probably keep working on it while I'm broadcasting. So what I'm doing right now is taking a bunch of the code that's in GitHub ecommit succinct binary. Which I will dump into chat. So this is the thing that I'm working on. And like earlier today, I guess it was about 6 hours ago, we got to a point where I had something that was writing more or less correctly, and then I did a little bit of work to clean it up and make it perform a little better. And so right now I think the thing I want to do is switch the guts of it over from just being an arbitrary pile of nonsense to something that is like I want to build a I want to merge my get and put stuff into one data type, because we were sharing two different walks for computing sizes, and like it was just we were walking the same data over and over again to do kind of redundant calculations. So serialize S result blob word 64 word 64 B. This is going to be L dot. Before the input, we feed it L. And here we do this thing and then so blob ij. We're going to call G on ij. G with that blob ij, and then we're going to serialize. We're going to do R on the result of it. Kind of a mess, but whatever. That's a profunctor. So now you can map backwards over the argument and forwards over the result type of serial. Get the serialization scheme for any individual data type. And then we'll build the generic serialization stuff directly, because we can't use the GHC generic stuff that we, or the generic SOP stuff that we wanted to, if we are going to start caring about strictness information. And then, if I remember right, so if I look at like rep for list, rep 1 for list, this is, I've got some data type. It's like a data type for lists. False, it's not a new type. It has two constructors. The first constructor is isomorphic to a unit. The second constructor is named const, which is infix. It has two fields, both of which are lazy. So the decided lazy is the thing that we're going to care about if we care about laziness. And what else do we need here? And the second one is like this rec1 thing. So in rep1, it uses rec1 to say, hey, look, I'm recursing into myself. And in rec0, it's in rep, normal rep, it's rec0, which is what it just does for you're recursing into anything. So if we build off of rep, then the thing I'm going to need to look at is to whether or not it's been decided lazy. And so generics SOP just doesn't give me that information. So I need to duplicate a fair bit of the logic from generics SOP to build the two lists of types that we were walking. Out of these things. And maybe I'll build it more directly as this. Okay. The other thing is that if I look at a new type, data functor identity, it lies to me. What is the rep 1 of identity? So here, a rep for identity, this says, hey, I'm a new type. But if we look at the field is decided lazy, even though it's a strict field because it's the only field of a new type. So there's a bit of subtlety if we're going to try and detect whether or not we're going down to a strict field. So if I have D1 with some metadata, and I know that this is true, and I can't actually just say D1, I have to use M1D. So, how are we going to do this? We're going to be able to convert. I want to be able to convert back and forth to a sum of products and a product of sums representation. Decided lazy is, okay, so let me go back to that. Pop out of that. GHCI, just general. Oh, it's already here on the screen. Okay, so there's three things. If we look at a field selector, this is telling me, does that field selector have a name? It's telling me whether or not it's been marked as unpacked or packed in the source. And then it's telling me whether or not the source has a strictness annotation. And then decided lazy tells me whether or not this thing is lazy or not, based on the extra information that you get from things like whether you have strict data enabled or strict enabled. Both of those can cause you to have fields in a data constructor that are either strict or lazy. Well, hello, Arcdamer. We are way down in the weeds of Haskell, so be warned. So we're going to need stuff like Haskell clickbait bids. Haskell is amazing and why you should learn it. Well, I agree with that sentiment. Haskell is amazing. How do I want to do this? I want to be able to say, I want to be able to build like a sum of products representation of a type that I can serialize into and then serialize back out of. And I need to know information about each one of the fields for size and stuff like that. Oh, fucker. We're going to have to bother to copy all of the stuff in from Blob and from Get as well. So I'll leave the Blob stuff off. We're not going to write the getter. We're just going to write the stuff to serialize. So that tells us all of this stuff, and we'll leave that off, serialize that. How are we going to represent a G-serializable? That's a really long name. No enclosure and tags. So yes, when you start writing Haskell, one of the things you learn is that there are certain keywords like do and where and of that make it so that everything below them is indented until it outdents. So the indentation of the next character tells you when things outdent, or when things move to the next definition. So this where at the top sort of sets the indentation of the whole file as the outermost position. And then inside of here we have like instance semigroup W where, and this stuff is a bunch of stuff that's talking about this particular class. Profunctor serializable. That's fine. What do you use class and instance for? So when we talk about Haskell classes in Haskell, we're talking about something they call type classes. Everything's still pure functional programming. It's a much different kind of idea than in other languages. I'll let maybe Puff and Fresh take care of that on the chat if he wants to talk about it more. Class G serializable where? Let's see here, we'll take two types. G serial, this is going to be T of A, T of A. There's going to be something like M1D, metadata, I don't care. Name, module, package, new type. Of something with one constructor, which I don't care what it is. Some field selector, which I don't care what it is, and some type. How's that for a mess? And I need to know whether or not this thing is... I need to figure out... what I'm trying to figure out is what the right encoding is this thing should live in if I'm going to track all this strictness information for all these layers. Thanks, IMTEL. I'm not quite sure what I'm doing at this hour. I just couldn't sleep. And if I'm going to be taking like a month break pretty soon, I figured I should get as much of this done as I can before I forget everything about it. So arctable, if you're familiar with the concept of like a V-table in like languages like C++ or something like that, where they talk about like if you have an object-oriented programming language, there's like a table that contains like here's the implementation of how you implement each one of the abstract methods. In a typical OOP language, you have to pass that V-table around with every object. Like, you know, the object carries around with it. Well, how are you like going to get the foo field and the bar field if they're overloaded? Whereas in Haskell, like that thing gets detached and can get brought together by the way these class and instance things work. And the way it works fundamentally relies on having really nice types. Which is why Haskell is really one of the, like, only a handful of languages that do it this way. If I had to rewrite lens in a dependently typed language, would there be interesting optics that embrace dependent types? Yes, there would. There's a few things that you can get out of dependent types for optics. One is that you can start talking about optic composition without having to have 4 type parameters with just 2. And then composing by associative fallback and stuff. The other one is that you can actually build up a notion of like a dependently typed lens, and it's an interesting construct in its own right. It's just rather difficult to talk about. I'm heading off to, what is my travel schedule? I'm heading off to California to help do a workshop for Miri. Then I'm heading to Seattle to do the Lambda World, I think, opening keynote. And then I'm going to ICFP. And so by the time ICFP ends, it's the end of the month. So I'm traveling basically from August 28th to September 29th. And my wife is joining me for like a week in the middle in Seattle while I visit Bartosz. This better be something like a K1. God, that's a mess. I don't know that I want to do this. Serializable P. M1, all of this crap. Metadata. C1 is M1C. S1 is M1S, I think. Yep, M1S. Whee! World's Ender, I don't know that there is anything really written up about dependent lenses. I did some fiddling around with them maybe 5 years ago, and I don't know if any of the Agda code from that ever went anywhere. I know a couple other people have written them up in Agda. M1C, M1S, CSP, metadata. How's that for completely unintelligible? K1 ICP. This is I need to. Data constructor. Constructor info. Here's how we serialize new types. Do I have an opinion on Ada? I'm actually really ridiculously pleased with how Ada has turned out. Rahul Matnini is a machine who seems to put out code at a ridiculous pace, and improvements to that. And so I have nothing really bad to say there. And Puffin Fresh here on stream is one of the core maintainers of it at this point. So every time I've needed something, it's just turned around and, oh yeah, that's just, it's being backported in, or it's there, or they've needed it for something else anyways. So like I needed Backpack, and they just finished porting Backpack back. I needed Template Haskell, and they just finished backporting Template Haskell. So it seems like it seems like they have all the right priorities to make it go in the right direction. So if you need to have Haskell run the JVM, Rahul seems to have the only serious story that I've seen for how to make that work, including a bunch of things that I usually complain about. You don't need to know OOP in order to learn Haskell in many ways. I think having an OOP background would get in the way. KPVW, hello. Haskell feels like programming before you start programming. I've read about its strength lies in making things easier to reason about, but isn't that after you've written the code? Coming up with equations in your head seems like work memory intensive too. I think the difference is that you can have equations to reason about your code in Haskell, where it's very difficult to reason about equations in a world where side effects can happen, especially if you're passing me a function. Like in an imperative language, if you pass me functions or other objects or something like that, I don't know what effects those things have on the world when I call their methods. So I have to worry about things that I can't see. And so what I find is useful about Haskell is the types are good enough that I can actually reason about what functions don't do, and that's almost as important as what they do. As a matter of fact, it's more important in a world where you write functions that take other functions as arguments. Knowing that that thing doesn't launch missiles is rather important to being able to like reason about how these things stitch together. The only thing that's really required to learn Haskell is to just learn and must be exposed to very foreign ideas. I agree with that. God, that is a mess, though. So what I want to be able to do is package this thing up into let's make some class for doing something like the sum of products representation, where I want a list of types, and I want to just have a do I want to have that, or do I just want to be able to go in and out of this thing at the correct type? Let's do it. Maybe let's fiddle around with this. So what does a sum of products look like if we were to actually keep this thing indexed on the raw underlying type? We would have something like what is my metadata constructor? This is my data constructor. It's going to be something like, here's an M1, an SOP of M1 for SOP. You give me one for some other type constructor at A, and I will give you an SOP of M1D metadata DCMDL package, and then I need to know whether or not this thing is true or false. And is there a GHC.type reps or something like that? Typelets. There's not, the singleton stuff isn't in here. It's in what's his butts package, isn't it? It's in the singletons package. This gives me back to the thing. So instance known bool true where reified bool. There. This is going to be allow, this is going to require allow ambiguous types. And I want this bool for this new type. And I want it as a what's a singleton bool? It's going to look like something like true is an sbool true. False is going to be an sbool false. Reified bool should give me something like, here's an sbool t. There. Now we've got type reflection for booleans, and I can do the thing that I wanted to do in the first place, which was just know whether or not it's a new type. And then we can walk into sums. So I want some kind of tree made out of sums to do the next layer of this thing. And then I'm going to need a the next layer of M1s. Do something like that, data TA. This tells me whether or not it's a new type. This tells me the tree of constructors. Here's the data type declaration type for that thing. This is a mess. Yeah, I started switching conventions to look more like my reflection library than the one that's in GHC. A reified bool. By the way, like one of the reasons why I'm streaming this as far off hours as I am, this is going to be as crackpotty as a stream as I go. Because I'm just trying to like write down the shape of this code at this hour. Yeah, Puff and Fresh, you have to be careful. At this point in time, I might just go with Gradle and Etless. I mean, now that you have, like, now that there's this whole reproducible builds thing. Which, by the way, is pretty magic. I have to give that to the Ada folks. I was not expecting that. I'll just leave this without the syntax. That's a data type. The constructors. Sum is going to take constructors, TA, LA constructors. So what do I care about the constructor? I don't actually care about anything that's in the constructor itself. M1C, whatever nonsense you want for that thing. Constructor TA to constructors. M1C, all that horrible nonsense, T. What else do we need here in order to just be able to fully walk this thing? My goal is to just be able to reify a class or something using generics into one of these data T things. It needs a better name than data. The backpack port is the problem. I could believe that. I don't know. Does the backpack stuff normally build on Nix? Can you just build like my unpack containers stuff in Nix? Unpack containers does work under normal. Oh, good. So I was wondering whether or not it was just like Nix didn't support backpack or something. So that sounds like it does. The backpack port is the problem. Huh. Some product. Okay, so Atlas is broken. Val says you give me. So we need to do like a field selector. So it says something like you give me a selector TA, and I will give you a field. These are cons. Cons is going to take fields TA and give you a constructor. So that's we've gone into the data constructor. Now we walk in, we have a bunch of data constructors. We're going to build this thing up. Here we go into products. We have fields RA, fields L product R, selector this is going to be something like you give me M1S, and then what does the selector constructor look like again? So meta cell has source unpackedness, source strictness, and decided strictness, and a bunch of other stuff. So I don't care about the field name. Source unpackedness, source strictness I don't care about. Decided strictness I do. So we're going to store an S-bool for the decided strictness and all this stuff. And that's starting to look like actual code. M1, all this stuff TA. Meta, all of this machinery. Rep 1, there it is. D1, metadata, next field. Something meta cell, next thing. Meta cell, the name of the field accessor, the two other things I don't care about, and whether or not we've been decided lazy. Decided strictness are these three values. So I want S decided strictness where S decided lazy is an S decided strictness for decided lazy. S decided strict S decided unpack S decided strictness. This is getting verbose. With the return type for the type GADT, I'm not sure. Decided strictness needs to take a type argument. T is of type decided strictness. Here T is of type bool. This is my funny SOP-like thing. I guess I can test all of this stuff can be tested independently of the stuff we're writing in here. Apologize for fiddling with the font size. So it's like, so he's like designing the structure of the program before he's writing it. I'm kind of writing it as a mixture. I'm not quite sure what the whole thing looks like. I know generally the set of parts that I'm going to need to stitch together. So my goal is to be able to take a reify a type as a type here. meta selector, and then whatever that type is, I'm okay. Cell T is an individual. Cell TA could be anything. So it could be a K1. It could be whatever we have down there. So this is M1S is the field selector, and then K1 is we have an S1 of da 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 da. So that's an M, and then here we have Rec1, which is K. What uses K1? There's a second use of the K1 type constructor. There's Rec0, which is a K1R. Is there another use of K1? There's all that UREC stuff for unboxed things, which I don't need right now. I don't care anything about associativity. I am going to care about this dot thing. But I think that's going to matter once we get into Rec1. Data rows A is rows list of Rep1 rows did, yeah, that's dot. Rec1 holding rows. List of Rec1 rows. Maxor, the idea of just pumping out code and then console logging until you get what you want. You can do, there's a deferred type checking extension for Haskell that lets you do much the same thing. You can write code that completely doesn't type check, and then whenever you go to run the parts of it that just don't make any sense, you get a delayed type error. You get a type error at runtime rather than compile time. I have not made that part of my workflow, but other people can do it. So right now this is just M1 something, and the selector is going to be a selector for K1 ICF. I don't remember what K1 looks like. K1 IC some value. Cell TA K1 ICB. Those are the only things I've got. So now what I want to be able to do is reflect a type and then take a value that goes with the reflected type and convert it into that type and back. Something like that. God, this is a mess. We're picking up our own constructors along the way. This is like a new type. Oh no, it's not a new type because it has the type witness for the type equality for that thing. Field. K1 ICA. This is just an A. And I should want some kind of constraint on it. I want basically a proof that all the parts hold some property. Maybe this would be enough to do it. Const property, all that stuff. Const fields T with that same property. Decided strictness, all this stuff. This stuff is pretty much independent of everything you're doing. Now we're at our types. Cons PLA, fields PLA, fields PRA, fields P, that thing, S lazy, selector that satisfies that constraint. And this should have something like field and here we should know P of A holds. Good night, Orc Tamer. I don't know if there's a thing that I can tell the stream to allow Profunctor bot to say more on my channel. If there is, let me know and I'll issue the command. G field PT. Where? What do we have here? We have K1 ICA. This is like K1 ACA, actually. K1 takes an ISC and a P, so it's IC and then the parameters ignored. So I need P1 for C. PC K1 ICA. Okay, so G field PT G field, you need to know P for that type in order to do it. You should be able to say something like, if you have a T of A, I should be able to give you a field PTA. I can't remember which way the GHC.generics from and to go. A to rep. A to rep. So from goes from A to rep. So I want to be able to walk this thing and how to put this? Generic field should be able to be constructed I want to be able to build a field PTA. G field is just a field PTA. Instance G field P K1IC this is a field for K1ICA. There we go. That looks much more plausible. G field P K1IC needs P of C. Then G field for that thing is going to take and just build. And we don't actually hold on to the C. We just have the witness of P of C. And to make it accessible as a type argument, so I don't need to use an extension that isn't yet released in GHC, I'll just pass a proxy that holds it. This is just K proxy. That's the only thing that we have that I'm allowing in fields right now. G fields PT where G fields is a fields PTA so we have G fields P L we have the induction on products. This is going to be something like G field equals product of G field PL This is field This is not S lazy, it's strict decided lazy. T. So singleton decided lazy is that thing. So instance reified decided strictness this is DS. So if DS is a reified decided strictness, then and we have a G field for T for PT. Then we have an instance of G fields And I might be able to jam all of these things into one data type with like separate type arguments, like indicating if it's a type constructor or all of this other stuff. But for right now, I'm keeping these as separate classes, and then we'll mutate it. Because there's just too many moving parts for me to think of the type recursion at the same time I'm doing all this other crap. G fields. What do we need to do with it? P M1 S metacell funsus dst. Type parameters left alone. And we just need to know cell. This is a selector. This is going to be reflect decided strictness. And this is going to be the field that I had before. This is a G field. I kind of like the idea of mashing these together into one type and then just having them be different. That way I have one class for all of this stuff. And then I type a parameter that tells me what this thing is given T and A. So gcons, instance gcons pt where, what do we have? Instance pcons gcons L or PL. Sum of gcons. So this is just G field because the types are fully determined, right? So I don't need to actually do type application. And then we have G field PT generic data constructors for P M1C CIT A. So the goal is to have this data type PT that I can walk down and get the proofs at the leaves that the things are whatever instance of whatever class constraint I wanted to put on them. So I can walk into the type, then walk through the sum structure over here, then walk down and keep going. And I don't have to like constantly do type magic and type classes. I just have this thing reified in advance, hopefully, as a data type that I can navigate. Gcons is S of G field. No, this is con of G fields. And then we have class G type PT where G type is a type PTA. for every A in advance. And I don't actually need the A for any of these things, so I might unindex it by that. If I ever go to do a version of this that takes the higher order versions of it, then that might bite me in the ass. But let's see if I kind of like that. G fields, all of that. Yeah, that's much cleaner. So now these things are indexed on something of kind star to star, which I'll have to clean up and fix down here at the bottom. So field P start constraint T as kind star to star. I don't need to write that. GHC will figure that out. But writing one just so we can see it might not be a bad idea. Const PT, they don't take an A anymore. They've dropped that parameter. So we can just do the induction on rep. I think. M1 of that type. Ignores the type parameter. I hope this is right. G type, type, PT. So instance G type. So we need a reified bool for whether or not we're a new type. And we need G cons PT. Gives me a G type for M1D metadata DC MDL package new type. Where G type is a type. PT. This is the reified bool for that particular type, and this is the cons, G cons. This is now a type PT. These don't need to have the type parameter anymore. They're gone. Man, that's getting fancy. Generics lets me walk up and down. Fields does all this stuff. We need GADTs. We need polykines. We need data kinds. We need constraint kinds. We need kind signatures. We need a whole lot more. Class G type. Now I can in scope. C1 is M1C. Where are the data C is it defined inside of GHC generics? Oh, it's just data C. I don't need to tick mark it. It's going to want flexible instances for this thing. All of this is going to take a type P, that. GHC types type. How are we doing so far? One or more arguments to K1IC. Well, I don't want to give you one more argument to K1IC. Field P. S decided lazy cannot be used here. What did I screw up? S decided strictness. Meta cell has kind meta. M1S meta cell, that thing. Field of M1. Did I screw up field? I did. I forgot to pass it P. M1S meta cell, all this crap. So you give me a single field. Oh, this is fields. Fields. Expected one more argument to M1S. Expected but kind K to star. L plus R takes one argument, or L times R takes one argument. Fields P, L, fields PR. I have fields PT. I have a single field for field PT. Come on. Expecting one more kind argument. One more argument too. M1S. M1S, this thing, then the next type parameter is the recursive type. Oh, wait, I got that wrong. What's a multi-parameter type class? Oh, yeah, those are multi-parameter type classes, indeed. M1 takes this extra type argument. That was just me screwing up. Tie. G tie P. Gefield, reified bool, S bool. This is reflect bool. Fields P. I need to know the appropriate field type. Damn it. Fields at. That's going to be annoying because I'm going to have to pass the fields manually. Go edge scoped. So G fields. Hey, check it out. This is gonna need some serious show magic. Almost there, getting this to be able to print. S decided unpack. Show string. Give me a tie where all the parts are, I don't know, readable. And I want to use it on a list of strings. Oh, this is not going to be, this is going to be rep. Data dot, oh, that thing's going to take the stupid argument, isn't it? Rep of list is this thing. We don't have an instance of G fields for U1. That's true. So let's go add U and V down here. No instance for G fields, read U1. G fields just give me a U1. What is the type that we're looking at here? Cell. If I don't have a meta selector, is that... Rep for you know, like a kind bang or something like that does the expansion. There it is. Kind bang. Rep for list of string. S1 meta cell. C1 metaconst U1. Just straight up U1, not a field. So U1 doesn't live as a field, it lives as a fields. and I didn't bake the G fields P all right, S false. I forgot to put a spacer in there. What other fields need spacers? Anything? Up here in S. There's the wrong name anyways. You're a tie. And you're spilling. We probably have a V1 for the top level as well. Good tie. Tie, S false, S constructor. U con P cell, S decided lazy, K proxy, S decided lazy. Have the information to determine whether or not. So now we can do induction against one of these things to build or tear down the stuff that we would otherwise build with generics, letting us do a lot of stuff at the value level rather than at the type level. That was not pleasant. Okay. So this builds my notion of generics. Is Obama really following me on Twitter? I have no idea. A lot of people follow me on Twitter. G field, PT. I was amused when Nolan Bushnell started following me on Twitter. I was like, I was not expecting the guy who founded Atari to start following me. I think I made some commentary about Go, which would explain it. Tie PT. So let's take this stuff and smash this thing into a single algebraic data type. What's the command line? Pasteboard copy. Make sure that's in my It is just GitHub come, just to make sure I've got it somewhere. Not that I'm really planning on doing much with it. Create a public gist. I should set the extension on that thing. Delete this gist. Yes. I screwed up its creation. New gist. There. That's the stuff that we just wrote. And that lets us, in theory, take a type and just smash it into something generic. Now, let's go back and clean this thing up. So this is just some reified, no nat singleton type silliness. But TypePT, I would like to let's just call it gen. Data. Generic type is Ty or cons or fields or field for now. And we'll smush this together into a single thing. Have I tried out PureScript? Quite a bit, actually. I think PureScript is about as nice as a strict language is going to get in my eyes. Like if you had to, if your mission was to make a strict Haskell so that you had very simple semantics for how you were going to evaluate, then PureScript succeeds very nicely in that mission. How does one figure out what numbers go into shows prec and show paren memory? So there are precedence levels that agree with like operator precedence, and so those go from like 0 to 10. And application is considered 11 under shows prec. So if D is 11, then it's I can't put spaces here. And so we need to put parens around this thing that wants a space in it. That's what I'm doing there. So gen Ty. Oh, no, I gotta deal with the problem that these things are named badly. Gen type. Just make this thing type or something like that. So my goal here is to be able to something like gen Ty and then cram all this stuff in there. And then we'll shove this stuff in here. And this is going to take a gen cons. This will take a gen fields. These 4 lines get mashed up into that. Hi, King. I just decided to keep streaming. I started it about 2 hours ago and dove back in. We have more things. Fields. This is a Gen Fields U1. And then down below we had these 5 lines worth of shows prac crap. And we should have like one more for kproxy for field. Gen field K1. Type S con P cell UK. Not very. Dreams are overrated. Tons, G fields, all this stuff is good. Now I just need to figure out how to smash all of these G field, whatever the heck, classes into one class. So gen PT such that T determines C. Gen PT mode T star or something like that. What is mode? It's going to be a gen type. And we're going to build a gen builds a gen of type TPT. So it should be something like a gen P something where type T equals tie. Oh man, I gotta write that whole freaking type out. M1D metadata DCMD package and TT is tie. And gconst is going to be gen of const. Oh, no. Oh, that's going to be annoying because I'm going to have to actually say something like that. Repeating T. Oh, hell no. We're going to go fundups. T determines tie. Ggen. What is this? Shaped IP shape gives back a generic of a thing. There is no class for this thing. We're just done. Type it. This is generic tie. I don't need this line. Type reflect bool gconst. This is just another gen. At p, the type is implied. This dies, and we get back to the meat of it. So this is going to be something like we deal with sums only for cons. Oh, we didn't call it gen, it's called shaped. Shaped tie, shaped cons. Shaped cons L plus R. And here we have shaped fields, PT, shaped cons, PM1C, this thing dies, this thing dies, this is shaped fields, shaped fields, shaped fields. This is, that's fine, but your shaped field, shaped fields. You are shaped fields. Field dies, show dies, all this dies. This is my generics stuff, reifying it all to the value level. And in theory, tie here is of gen type. Should have figured that out automatically. Shape. Well, that's annoying because I want the type parameter p to be first. So I have to put the p before the tie here. Oh, that's going to mess with my... Just do that. Or you can probably take the P anyways, because it skips parameters that don't have the right kind, right? That would be nice. Let's just try it and see what works. This is technically G shape, but... shaped fields, shaped cons, shaped tie p. Do need to do the tie pt. All right. We can show a generic thing of that sort. We need flexible context now. I guess I can't skip. Will that actually work? G shape should give me back a shaped not a shaped tie. This is a gen tie. G-shape, gen tie, read. So given G-shape, I should be able to define shape, which says if I have a generic A and shaped type, or shaped tie, yeah, I guess I can't really do that. That's the wrong kind, and I don't want to. Shaped tie. PT. For all P, for all A, T is now rep of A. I will give you a gen tie P rep A. G shape at P at rep A. Which scope type variables we do? Gen type P rep A. This time we need to allow ambiguous types. Well, clearly I screwed up. G shape at tie. genty read type. It is not a new type. It has sum of a single constructor, which has a unit, no arguments, followed by a product of a lazy field, which we're going to say is this thing. And it has another field which has been decided lazy, which is that thing. All right, now I can do all my induction on values. And we know that when we get down to the leaves, these proxies have all the information to know that that C is an instance of P. Shaped tie. Shaped P. Still got the benefit the other way. We use the class alias trick. G-shaped tie. I should be able to do something like this. New type shape PA is shape holding on to a G shape tie for this parameter for rep of A. Shape, G-shape, all that stuff. We've got that thing. Void is a rep, it is a data constructor, and then we go into the sum and we get a v1. is a G-shape fields. No, G-shape cons. PV1. Then this represents a data constructor, but I didn't store any of the information about the name of it or anything. Field selector didn't store anything about the name of it. This gives me everything I need to do induction on some form of generic shape. '96 is a G shape. Rep. Shape P. Hey. Give me the shape. I want a shape for read for string. I don't have an instance for shape. Shapes are of the form, every one of these things is a instance eq shape PA where they're always equal. And in theory, we can support read. Okay. Now we have fields. I could in theory include like the data constructor names and all this stuff, but I'm not using it. If I was building this as a library for other people, maybe that would be the direction I would go. Typed S1 false as false. Con SU, con P. Cell S disallowed. Decided lazy. All of that, I think, makes sense. The only other thing to do would be to define rep1. And that guy would let us talk about rec1 usefully. Rec1 list. And take the type parameter A. So con is really our data constructor. Takes all the fields and builds a single data constructor. Whew. Okay. Data binary succinct generic. I would like to be able to do something like compute some kind of summary as well. These things, like, so for computing sizes and stuff like that, if we were to stuff the size annotated inside of the shapes we get, we would do better than this can allow. So what do we have? We have shape. We have reified, decided strictness. We have G-shape. So now shape. So what are internal things. Reified bool, G-shaped, and reified decided strictness are all internal concepts. Shaped, shape, shaped, and shape. All right, that type checks. And now we ask for the shape. Can we read all the things in a string? Can we enum all the things in a string? No. So let's make sure that this thing works for like data. Foo is foo. Word for foo. Foo is made up out of parts that are all instances of that's true. Shape run shape type S false console S decided lazy K proxy. All right. Read would be quite tricky for this thing because you need to recover the type information as you're reading. I think Gershom gave a talk on how to do that at one point. I don't remember the exact trick. It involved unsafe course at some point. Shape Jafu. So I want to be able to put annotations on these things. So that would require me to be able to put a couple of type annotations, one here and one on each constructor or something like that. And then be able to build those from G-shaped constructors and S-bool. So I want constructor annotations, selector annotations, and type annotations. It's almost like the trees that grow kind of scheme. N type PT. N type PT. And we need some other annotate a field selector. Annotation and P. So I want to be able to do something like you take an S-bool NT and a G-shape constructors PT. Give me a type N. You give me a type take a G fields, G-shaped field PTs. Give me an N fields PT. Give me a selector annotation, and that will take a and so PT. Data. What I'm currently doing is building a small generic programming library for Haskell that is taking the contents of GHC generics and then reifying them down to the type level, or to the term level, so that I can walk them with just more or less traditional Haskell, rather than having to do all sorts of crazy type level metaprogramming. Unannotated. Takes a gen type and P, which is going to be anything of kind start a constraint, and a type. We have an annotation and type PT. We don't need that. I don't need to know P and T. Those are known. T is not known. N type T and constructor T. Annotation here would say that those are compatible. P unannotated doesn't actually contain the constraint. Unannotated. So an unannotated annotation says type annotation, ignore these two arguments and just give me back unannotated. Conan. Celan. Is generic programming in Haskell the same as C++? Not really. There's very little comparison between what I'm doing right now and what you can do in C++. This is a lot closer to like Java reflection. We're looking at Haskell data types and then peeling apart what fields and what parts they all have and turning that into a data type that witnesses the thing that we can walk up and down through. It's a very loose analogy to Java reflection. But so G-shape and, but I didn't pass the and through everything here. Ugh. G-shape and G-shape and G-shape and G-shape and G-shape and for all annotation types, this is a G-shape and. So that plumbed all of our annotation stuff. We can show G-shape as long as we can show annotations. Int n tie t to a shows. C++ template. They're harder to read. I don't know that they're more sophisticated. But yes. What we're doing here is we're building up a set of generic terms that work over. Like each one of these, you could view these almost like you could view these as a C++ template. One of the things that drew me into Haskell was how much easier it was to read Haskell code, even when it got super ridiculously polymorphic, compared to the equivalent C++ template metaprogramming. And this is not the best intro to how to read Haskell. Con has an annotation as well. And I shoved another annotation down in Selector. Shows prec and 11a.showchar. Normally this stuff would be really automated. Unfortunately, when I'm down fiddling with all this generic stuff, all the usual stuff for making all this stuff automatically work falls apart. Show and lets me show any generic shape. And then down in shape, This is going to require us to have shaped and so I need an annotation. This is an annotation for all classes. So I need an annotation and P. And G-shape is going to pick up another type parameter, which is going to play hell with all the rest of this stuff. So here's my annotation. Wow, this stepped clear up into pipes territory. G-shaped. Does G-shaped actually require the annotation? No. The class doesn't actually take the annotation into account. We can build this for any annotation as long as there's an annotation for NP. Shaped and PA. Tie PT and tie PT. This will figure out the annotation afterwards. Shaped annotation. No, shaped doesn't take the annotation. Shaped PA. There's P is constrained on all of the leaves of this type. And we know that there's an annotation that P is that N is a valid annotation on P valued things. And the idea here is that I want to be able to build size annotations that are like the ones that we were using the other day. And this will let us go through and do all of the succinct data structure stuff that we wanted. So this lets me pull out annotated generics for each individual type, hopefully. Navigate up and down them using normal terms. So type here is interesting because I want to build a smart constructor for type. Type underscore G-shape and tie PT, and we need to know annotation and matching on it will tell us tie. We need to know annotation and P. And what does type hold? It holds on to whether or not this is a new type. This is sbool nt. Wow, that's... G-shape and constructors PT. And you build a G-shape and tie P. This god-awful mess. And we match on type underscore, ignoring the annotation. And we build with this with type, and we use n type, NTCS, NTCS. So when I pattern match on this thing, I learn nothing. I mean, I guess I learned that this is a constructors or something like that. Then I'll do patterns for con and all that stuff later. And here we have a type. I don't want to give you the ability to write to type. So I don't need to actually show you the annotation. I guess I want to show you the type annotation now. Type con, that'll show the annotation. Shows prec n. The other one is another annotation. We're going to need to turn on pattern synonyms in this file. Data constructor cell cannot be used here. It's not cell. What did I call it? It was called... and fields. And constructors. Line 80, 81. We take a G shape for this annotation. Take a G shape for that annotation. We take a G shape for this annotation. Cat? I'm not quite sure where I follow it. Oh, are you hearing the cat in the other room yowling? I could believe that. He's kind of noisy. He's kind of needy. Cell. He is really determined to get my attention. And so we were annotating cell, con, and type. And in the end, the whole point is I'll be able to do this. I just need to make the synonyms for cell and con. Con holds on to this crap. Pattern con holds on to the only field we have. And con, G shape, and fields. No, what is cell? Cell holds on to a bunch of crap. Drop that. Come down to this stuff. Cell. So this has a strictness and a field. Is a cell underscore a d's f. Cell con d's f. And cell. D's F. What's the last couple of things? We've just got F's. No, D's F. Decided strictness, 181. Reflect decided strictness. (181) is a cell underscore. Cell takes cell underscore D. This is cell. That was just stupidity. Getting there. And type. So we have and con. Type and con and cell and. Alright, now with all of that, I should in theory be able to build shape unannotated ord. I don't have a foo. String. List of strings. Show and unannotated. I don't have that. Unannotated. Shows prec and the unannotated show string. Type unannotated. Con unannotated. Selector unannotated. Okay. That's starting to come together. If I were to turn those into a list of lists of cells. And the cat finally gave up. So if we had some kind of sized thing, we could then compute annotations for size for all of those things. We need gen type as well. And we have show n. Annotation, show n. Unannotated. Gen type is needed in order to implement annotations, regardless. Shape is there, G shape. Type unannotated, con unannotated, con unannotated, cell unannotated. And those are the only layers I'm annotating for now. This would be a case where maybe you want to backpack this. You'd probably want to pull the annotation out entirely into the backpack and say, here's the set of annotations I'm going to apply. You might be able to do the same thing for that parameter p and get this thing down to something that a human might want to read. Because then you'd be down to 2 parameters uncurried in the data type. I could see that being tolerable. Unannotated is going to have to slowly move down here. 5 lines further down. So in theory, if I were to export type and con and cell and not export type without the type with the if I didn't export type, con, and cell, then the eq and ord stuff that I have would be unique properly. Show. We need to move these annotations out of the way. Yeah, these things move. Annotations, show an. Generic shape. For all tie t, tie is of type gen type, t is of kind, star to star, int to an, tie. Gen type. Star to star to star. is already known to be of this type. Here we go. So I don't need to pass these explicitly anymore. This is something like gen type. Okay, shaped generic. G-shaped type P rep A. Actually type checked. Shape unannotated. Word string. Show currently shows the annotations. So we built a sized class, we could build size annotations. And they would just work. And that would let us do all of the... So we needed to figure out like size annotations, whether or not it's strict. And like stuff for figuring out constructor numbers and stuff like that. That's the stuff we need to build on top of this. So I guess we've streamed for maybe 3 hours now in the middle of my night. Maybe I should wrap this here. All right, yeah, I think I'm boiling under these lights, and it's 5 a.m. So I will pick up here maybe later. I'll probably do more of these little off streams, mainly because I'm going to be gone in just over a week. And might as well get some content backed up. All right, I will catch folks later. Is anybody streaming?